Today we're embarking on a journey through the cosmos, delving into its essence, origins, and fundamental components. We'll investigate the intriguing notion of how the future gives rise to the past, which in turn shapes the future. But first, let's discuss crystals. Contrary to what you might think, a crystal isn't just an ornate piece of glass or a chandelier in an opulent dining room. In its simplest form, a crystal is defined by a repeating pattern. Take a look at this checkerboard pattern. Notice how it extends infinitely in all directions? That's what we call a periodic pattern. It's a two-dimensional crystal. Here are more examples of two-dimensional crystals. But crystals can also exist in 3 dimensions. Interestingly, this piece of glass is referred to as a crystal because its atoms are arranged in a periodic crystalline structure. Now, what happens when we project a 3-dimensional crystal onto a 2-dimensional plane? The resulting image on the ground appears distorted due to the projection angle, forming a pattern that lacks periodicity. Therefore, it's not a crystal. However, there's a profound relationship between this 2-dimensional projection and the original 3-dimensional crystal. This distorted pattern is known as a quasicrystal. Essentially, a quasicrystal in a lower dimension, 2D, is a projection of a crystal from a higher dimension, 3D. A team of physicists is developing a groundbreaking theory centered on an extraordinary 8-dimensional crystal. When this 8D crystal is projected at a specific angle into 4 dimensions, it forms a 4D quasicrystal. From this 4D quasicrystal, they derive a 3D quasicrystal, which they propose as the fundamental substructure of reality. At the core of this 3D quasicrystal lies a fundamental unit, the tetrahedron. This 3-dimensional equilateral triangle has edges that are the smallest possible length, known as the Planck length, approximately 10⁻35 meters. Consider how a TV screen is composed of tiny building blocks called pixels, the smallest indivisible units of a 2D image. Now, imagine reality as a 3D version of that screen, where tetrahedra serve as 3D pixels, the smallest indivisible units of reality. These tetrahedra combine according to complex mathematical rules to fill the entirety of space. Each tetrahedron can only exist in a limited number of states at any given moment. The rules governing their connections mean that the state of one tetrahedron influences the states of many others throughout the universe. This raises an intriguing question. If a tetrahedron can be in one of only a few possible states at any moment, what determines its specific state? To answer this, we must introduce a new element into physics: consciousness. Surprisingly, even the exact value of the speed of light remains elusive. We have close approximations, but the exact value eludes us, limited by the precision of our instruments. No matter how advanced our technology becomes, we will never measure the exact speed of light without a theory that explains its value and significance. Current physics theories, such as Einstein's theory of relativity and quantum mechanics, take the speed of light as a given without elucidating why it is what it is, or why the universe imposes such a speed limit. This points to the need for a new, more comprehensive theory. Emergence theory aims to shed light on the speed of light and other fundamental constants, such as Planck's constant and the fine structure constant, of a theory of everything, an overarching framework that explains the foundational aspects of reality. String theory, once a promising candidate for this role, has yet to make successful predictions and falls short of being a true theory of everything, as it cannot account for the speed of light or these other constants. While quantum mechanics and general relativity provide accurate predictions, they too fail to elucidate the fundamental constants. What hints does nature provide for constructing a theory of everything? Consider the following elements: information, causality loops, non-determinism, consciousness, pixelation, the E8 crystal, and the golden ratio. These clues may guide us toward a deeper understanding of the universe's underlying principles. A growing contingent of physicists propose that reality is fundamentally composed of information. But what does this actually mean? Information, in this context, is meaning conveyed through symbols. Language or code is a common form of symbolic information. However, there's another kind of symbol that directly represents itself: geometric symbols. A triangle, for example, can represent abstract concepts like love if we assign it that meaning, or it can simply and objectively represent itself. Could there be a language or code based on geometry? And what kind of information would such a geometric language convey? Both quantum physics and classical physics suggest that reality is composed of information, with no compelling evidence that it consists of anything else. This idea is gaining traction among many physicists, though it remains a topic of debate. Reality appears to be inherently geometric. A geometric language composed of symbols that represent themselves might offer a framework for understanding how a geometric reality could be built from pure information. Information inherently carries meaning, but what exactly is meaning? Meaning arises through comparison. It's a process we perform so rapidly that we hardly notice it. We identify an object by matching it to a mental database. That is a cupcake. That is a house, not a car. That is a painting, not a tree. Meaning, therefore, is the perception of one thing relative to another, making it inherently subjective and necessitating choice. For meaning to exist, it must be perceived or measured by some form of consciousness. Thus, the concept of meaning, rooted in information and realized through geometric symbols, points toward the essential role of consciousness in perceiving and interpreting the fabric of reality. Einstein revealed that the past and the future coexist within a single geometric construct, suggesting that all of time exists simultaneously. This concept challenges our common sense, yet it aligns with the best mathematical and physical theories available. Imagine the entire universe frozen in a single moment, like a single frame of a movie. Each frame captures reality at one point in time. Movies, with 24 frames per second, create the illusion of movement from these static images. Similarly, there's a smallest unit of space called the Planck length, and likewise, there's a smallest unit of time, an incredibly brief 10^44 seconds. Visualize this frozen frame of reality, the entire universe in one moment. Now, imagine the next frame, slightly different, and so on. In Einstein's space-time, all these frames exist simultaneously. This brings us to a perplexing idea. While we usually think the past influences the future, why can't the future influence the past as well? Why do we label one side of the block as the past and the other as the future? If we remove these labels, we could conceive of a scenario where the past and future influence each other in an endless feedback loop. The past affects the future, and the future affects the past, continuously. So, which part of the past influences which part of the future, and vice versa? The answer is that all moments in time affect each other continuously. Could your actions 20 years from now influence you today, just as your actions today influence your future self? Could the you from 5 minutes in the future affect you from 10 minutes ago, in the same way that your childhood self influences your life now? This concept is difficult to grasp, but it aligns with our understanding of reality. If every moment co-creates every other moment, both forward and backward in time, reality would resemble an immense neural network spanning across time and space. This network would possess an astonishing quality. It would be its own creator. The notion that all time exists simultaneously does not imply that the future is predetermined or that we are merely programmed automatons. This deterministic view, once popular, suggested that reality unfolds like a pre-written script. However, the famous double-slit experiment challenges this perspective. If you're unfamiliar with the double-slit experiment, check the link in the description. It's a pivotal piece of modern physics that debunked determinism and introduced the concept of non-determinism or free will. So how does free will fit into this picture? One of the most astonishing revelations of quantum physics is that particles only manifest when they are observed. In essence, reality itself appears to depend on observation. John Wheeler, the physicist who coined the term black hole, proposed that reality is constructed from information generated by observation, which must be performed by a conscious entity. Frank Wilczek, a Nobel Prize-winning physicist, argued that quantum theory remains contentious and opaque until we incorporate an observer model into its formalism, essentially, an entity whose states mirror conscious awareness. This model doesn't necessarily have to be a human or animal, but should be capable of generating information through observation and measurement. Consciousness is a fundamental yet enigmatic aspect of the universe. It is profoundly connected to physics in ways that are still not fully understood. In fact, consciousness is one of the most mysterious phenomena in science. If reality is indeed pure information, encompassing energy, matter, and thought, it suggests a deep relationship between consciousness and the fundamental fabric of reality. Could consciousness and information be intertwined in a causality feedback loop, shaping each other in a fundamental way? This possibility hints at a profound connection between the nature of consciousness and the structure of reality itself. Werner Heisenberg, a pioneering German physicist, laid the groundwork for quantum mechanics using matrix theory, which led him to the insight that space and time are fundamentally pixelated. This pixelation, akin to the discrete pixels on your computer screen, occurs at the Planck length, the smallest possible unit of space. This mathematical prediction suggests that spacetime is divided into these indivisible units. While solid experimental evidence for a pixelated spacetime is still lacking, the consensus among scientists is that space cannot be smaller than the Planck length, reinforcing the notion of a pixelated reality. The quest for a quantum gravity theory that fully explains this pixelated spacetime remains unresolved. One intriguing clue from nearly a century of particle physics experiments, including those at the Large Hadron Collider in Geneva, is that fundamental particles and forces transform into each other through a process known as gauge symmetry transformation. These transformations correspond to geometric shapes, specifically an 8-dimensional shape that forms a crystal structure. This 8-dimensional crystal is known as the E8 lattice. Crystals are characterized by periodic patterns, much like a checkerboard pattern made of squares. The E8 lattice is a complex 8-dimensional structure with 240 vertices, referred to as the Gossip polytope. When this E8 crystal is projected into 4D, it generates two shapes of different sizes. The ratio of these sizes is precisely the golden ratio, 0.618, a number that frequently appears in nature and mathematics. Thus, understanding how these geometric patterns and transformations relate to the fundamental structure of reality could offer profound insights into the nature of spacetime itself. The golden ratio may be the ultimate constant of nature, embodying a fundamental ratio that pervades various aspects of the universe. This ratio is intrinsically linked to circumscribed equilateral triangles and intriguingly appears across scales from the quantum realm to cosmic phenomena. Notably, it is present in the behavior of black holes. The golden ratio marks the precise point where a black hole's modified specific heat transitions from positive to negative. It also features in the equation for the lower bound of black hole entropy and connects the loop quantum gravity parameter to black hole entropy. Why does this support the idea that the golden ratio is a fundamental constant? A theory of everything aims to unify general relativity with quantum mechanics, and black holes represent the intersection of these two theories at their extremes. Matrix mathematics, which is distinct from the science fiction concept of the matrix, is a branch of mathematics used extensively in quantum physics. Matrices are arrays of numbers arranged in columns and rows, with various possible combinations of these numbers. For example, a matrix with 4 numbers can have 24 different arrangements. In quantum mechanics, matrices are binary, containing combinations of just 2 numbers. Each combination has a corresponding value known as an eigenvalue. Eigenvalues can be trivial, such as 1, 2, and 0, or non-trivial, more complex numbers. Interestingly, the most probable non-trivial eigenvalues found in binary matrices are the golden ratio and its reciprocal, -1 divided by the golden ratio. This reveals a profound connection between black holes and quantum mechanics, as the golden ratio appears prominently in both fields. The golden ratio manifests with remarkable precision across a wide array of phenomena, from the microscopic to the macroscopic. Its pervasive presence suggests that its role is far from coincidental. Historically, the golden ratio's appearance was often dismissed due to a lack of explanatory frameworks, relegating it to the realm of amateur science. However, with the development of a rigorous quantum gravity theory, the golden ratio is now predicted to be a fundamental feature throughout the universe, reinforcing its status as a key constant in the fabric of reality. What might a theory of everything look like that incorporates the 7 clues we've discussed? Information, causality loops, non-determinism, consciousness, pixelation, the E8 crystal, and the golden ratio. At its core, reality could be envisioned as a mosaic-like code or language operating at the smallest possible scale, known as the Planck length. Data from particle accelerators suggests that all particles and forces are interconnected through a higher dimensional crystal structure, specifically the E8 lattice. Given that our observable reality is 3-dimensional, we project a slice of this E8 crystal down to 3 dimensions, yielding a quasicrystal code or language. This geometric language then forms the foundation upon which the particles and forces of our world are constructed. This geometric language, much like any other language, operates under specific rules, but also allows for syntactical freedom. This introduces the concept of a chooser to make decisions within this language. Randomness, as a concept, struggles to fit into a structured code, where meaning becomes fragmented. Furthermore, there is a lack of substantial experimental evidence supporting true randomness in nature. A universal collective consciousness is one proposed solution to this issue. While this idea may seem New Age or religious, many physicists now entertain the notion that our universe could be a code-based simulation running on an immensely powerful quantum computer in another universe. If this hypothesis holds, that other universe would similarly be a simulation within yet another universe, creating a potentially infinite regression of simulations. Despite its speculative nature, this idea is taken seriously by some credible scientists. However, the concept of a universal collective consciousness need not be anthropomorphized or imbued with spiritual significance. Consider the behavior of cells in your body. Each cell is a simple life form with its own decision-making capabilities. These cells, in their simplicity, chose directions to move, pursued nutrients, and avoided dangers. Over time, these individual cells organized into colonies with enhanced collective awareness and decision-making abilities, eventually giving rise to complex organisms like humans. This collective organization of cells, governed by physical laws, led to the emergence of sophisticated consciousness. The laws of physics facilitated the self-organization of electrons and quarks into stable atoms, which further organized into conscious systems like human beings. There is no upper limit in physics on the amount of energy and matter that can organize into such systems. Thus, a universal collective consciousness, in some form, may be a natural and inevitable consequence of the physical laws governing our universe. The inevitable emergence of universal consciousness. Physics opens up the intriguing possibility that all the energy in the universe could eventually coalesce into a singular conscious entity, a vast, technologically advanced collective consciousness composed of interconnected conscious systems. Given the principle that, given enough time, everything that can happen will eventually occur, this universal consciousness might already exist in some future frames of space-time. If such a system is possible, then it is also inevitable. Moreover, evidence from retro-causality and time loops suggests that this future consciousness is not just a distant possibility, but actively participates in shaping our present reality. In essence, this future consciousness is co-creating our current existence, just as we are contributing to its emergence. Thank you for tuning in. If you enjoyed this exploration, be sure to like, subscribe, and share your thoughts in the comments below. Let's continue to unravel the mysteries of existence together. Stay curious, stay kind, and remember, we are all intricately interconnected.